All right, ladies and gentlemen, we are looking at commonly missed questions. So we are in problems 1 through 6 to determine if the triangles are similar. If they are similar, then we are to complete the similarity statement and state which theorem we use to determine that they are similar. Okay, so remember that we are looking for one of three things. We are looking for all three sides to be proportional. That would be our side, side, side. We are looking for two angles to be corresponding. That would be angle, angle. And then we are looking, the third thing we could possibly have is our SAS, which is our two sides that are proportional and a included angle that is corresponding. Okay, so as we go to look through here, our first one, we can see that in blue here I've matched up, let's start with yellow. In yellow here I've matched up the smallest side, 3.6 to 5.4. That is this fraction here. And then the blue is the next smaller side, 5.2 to 7.8. And that is this fraction. And then the third is 7.3 to 10.95, which is this fraction here. Each one of those fractions, when turned into a decimal, is approximately 0.67, or reduced as a fraction 2/3. And so that tells me I have all three sides in proportion, and so therefore my similarity is side, side, side. I want to make sure that I do the similarity statement correctly. So if this one was named FEB, so I'm going to start with F here. Notice that the colors help me here because I'm between yellow and blue. So that means that over here I'm going to start with J between yellow and blue. The next thing here was E. E was between the blue and the red. And so I know that over here the next one I'm going to go to is N, between the blue and the red. So remember, we're making paying close attention to making sure that those similarity statements are accurate. All right, if we look at number two, I first see that we have an angle here and an angle here that would be corresponding. So that means that I'm looking for either another angle or two sides. And what I notice is that this side here, 6, is going to be in proportion to this size over here, which is 10. So that 6/10 reduces to 3/5. If I look for the other side here, I could see that this is 9, and this part is 6. So that means this whole part must be 15. So I'm doing this pink part in here, 9, and then to this whole part here, which is 16, which also reduces to 3/5. So I have two sides in proportion and one corresponding angle, which is going to be side, angle, side, similarity. And then I'm going to be careful that I match this up correctly. So if I look at this, I know one thing for sure, that this angle B has to correspond to this angle B. So that's one thing I need to make sure of. And then I need to make sure that, that BD here is corresponding to CB. So there's my GB corresponding to CB. So just make sure that when we're writing that similarity, that we have the correct sides. Okay. If we look at number 3, if we look at the interior angles here, you can see that we have a 47 and a 47, which are corresponding. But then if we look, this is 68 and 59, which is not. If we do interior triangle sum here, this would be a 65. This would be 74 over here. So we don't have corresponding angles that are congruent, and so therefore there is no similarity statement because we don't have a theorem that makes these triangles similar. Looking at number 4, Number 4, we have to do a little bit of work on, and you can see that we are given right triangles here. So the one thing that I need to do is figure out the sides. Since I'm given that this is 90 and this is 90, I can't use any of my side or angle because I'm giving no other information about angles. So I have to try to look for side. And so I need to know the measurements of the other side. So I have to use the Pythagorean theorem. So here in purple, if we know one of the legs and one of the hypotenuse, I'm going to take that 10 squared, 100, minus the 5 squared, 25, and it's going to give me 75. 75 has a perfect square factor of 25, and that's how I get that 5 radical 3. So that first step is just figuring out what that side is. Same over here, except this time I'm looking for the hypotenuse. So I'm going to have 3 squared is 9. And then if I take 3 radical 3 and square it, that'll give me 27. And if I add those together, that's going to give me 36, and the square root is 6. And that's how I know that this hypotenuse is 6. Okay. Now if I start to look at my corresponding sides, I will have 5, or proportional sides, 5 to 3, and so that's that 5/3. And then I have 5 radical 3 over 3 radical 3, which is right here. Those radical 3's will cancel out. That's still 5/3, so that's in proportion. And then 10 over 6, which is this fraction here, which is, once again is 5/3. And so since all 3 sides are in proportion, that is side. All right, let me go ahead and move this up. If we're looking here, we can see that we have a corresponding angle 62 and a corresponding angle is 62. If we go to look at our sides, we would notice that what's going to happen here is that although we have sides that are marked off, the angle is not the included angle, and so therefore this cannot be side, angle, side. We don't have enough information to do angle. We don't have enough information to do side, side. And so therefore there is no similarity statement and no similarity theorem that we can use to prove that these two triangles are similar. If we look at number 6, we can see that we have vertical angles that are here, so mark those congruent. You can see that we have angles that are already marked congruent, so we have 2 angles, and so we're going to be able to use that angle similarity. And notice that over here with this one, they have started with J, then U, and then L. So with this one, we're going to need to start with A to go to U next, so that our U's are corresponding, and then to G, so that the G and the L are corresponding. Alright, I'm going to stop the video at this point, and I'll pick this up in a second video.